All right, so first of all, the instructions when they give you the interval will be a bracket on the 0 and a parentheses on the 2 pi. What's the difference between the bracket and the parentheses? 2 pi is not included. So if you have an answer and it's at the x-axis on the right where 0 is, you give the 0 answer, not the 2 pi answer. Does that make sense? Okay, that's how the instructions will be. They'll either be like this or they'll be without that completely, and then you add on your interval. So when it says it like this is when you use your natural unit circle, right? So if it doesn't have a restriction like 0 to 2 pi, then for sine and cosine, we use the full circle and we add 2n pi. And for tangent, we use quadrants 1 and 2, and we add n pi. So if it didn't have those instructions, if it didn't say on the interval of 0 to 2 pi, then we follow that pattern. But this time, obviously, it says 0 to 2 pi. So for the first one, I'm going to work through the right side of it, and then I'm going to come back to that tan 3x because it's different, and that's the multiple angle that we didn't get to yesterday. So I'm going to pretend like that's not there yet. I'm going to work out this right side, which basically just says tan of x minus 1 equals 0. So tan of x would equal 1. And then I would go to the unit circle. So if you want to be practicing with your unit circle, feel free, because remember, I'm going to give it to you. But also, I mean, the better you know it, the faster you're going to be at it. So I would look around my unit circle for where tan is positive 1. We know tan happens at the over 4s, and tangent is positive in quadrant 1 and in quadrant 3. So the answers there would be pi over 4 and then 5 pi over 4. If it gives you the restriction, you don't, right? So if it doesn't give you that restriction, then you use first and second and you add n pi. If it does give you the restriction, it's basically overriding that. It's basically saying ignore what you normally do and only use 0 to 2 pi, but use all of 0 to 2 pi.
So if it would have been without the restriction, the answer for the tan one would have just been pi.
Plus n pi. Yep.
Wait, what did you do to the tan?
I said I'm going to come back to it because it's a multiple angle one. We didn't get to that yesterday. Who's got their earbuds? All right. 2, right, is our secant. There's a squared and there's a non-squared, which means we get everything to one side because we're going to have to factor it. So secant squared x minus secant x minus 2 equals 0. And then I can factor it. You can sub in that a if you want the a squared in the a, or you could just work with what's there. So secant x and secant x. And then the factors of negative 2 that would sum to a negative 1 would be negative 2, positive 1. Split and solve these, and I get secant of x equals 2 and secant of x equals negative 1. Secant's not on my unit circle, but cosine is, so we flip both of these. This would be cosine of x equals 1/2, and cosine of x equals, the reciprocal of negative 1 is still negative 1. It's cosine, so I'm looking at my x values. I'm going to go to my unit circle, and I'm going to look for wherever my x is. Let's start with a positive 1/2, which happens here and here, and then where it's negative 1, which is here. So if I was putting this in order of least to greatest, which is what the instruction's going to say on the test, then I'm going to list first pi over 3, then pi, and then 5 pi over 3. If this is an open-ended question, I'm typing this in. This is pi/3, comma, no spaces, pi, comma, no space, 5 pi/3. Questions on that one? Okay, so then 3 has both secant and tangent. I know I need to get them to be the same one. My advice is to do the ones that are already on your unit circle or that you've added, which means tangent. You can have changed, because they're both squared, you can change either one this time. If it's just secant squared and tan to the first, then you're replacing secant squared. You're replacing whatever's squared. But this time you have choices because they're both squared. So my Pythagorean identity is that it would be tan squared x plus 1 equals secant squared x. So I can basically just take secant and replace it with tan squared x plus 1. Then I would distribute here. I'd get 2 tan squared x plus 2 plus tan squared x minus 3, all this equals 0. Combine your like terms, so 2 tan squared plus tan squared would be 3 tan squared. And then positive 2 and negative 3 is negative 1. I only have one tangent, so I can solve this by adding the 1 to the other side. I'd get 3 tan squared x equals 1, dividing by 3, and I get tan squared x equals 1/3. Square root both sides, putting a plus and minus in the front, and I get tangent of x equals plus and minus the square root of 1, which is 1, over the square root of 3, which gets rationalized to root 3 over 3. So because it's plus and minus, I'm looking for all the places tangent is root 3 over 3, positive or negative. Those are all the over 6's. So this is pi over 6, this is 5 pi over 6, 7 pi over 6, and 11 pi over 6. Yep.
Can you do it the other way where you replace tangent?
Sure. So tangent would be secant squared minus 1, so 2 secant squared x plus secant squared x minus 1 minus 3 equals 0. So I get 2 secant squared x plus secant squared, well, let me combine those terms. I'd get 3 secant squared x minus 4 equals 0. 3 secant squared x would equal 4. Secant squared x would equal 4/3. Square root both sides, doing the plus and minus, so secant of x would equal plus and minus the root of 4, which is 2, over the square root of 3, which has to stay that way. Then it's not secant, it would be cosine on our unit circle, so we flip this and we flip this side. So now I'm looking for all the places that the x is plus or minus square root of 3 over 2, which is all the over 6's.
Thank you.
You're welcome.
You were able to actually exist on that one?
No, it's the same answer. They would both be the same. They would both be this. Yeah. It's all the over 6's. It's just 2 ways to do it. Questions on the warm-up? Again, we're going to go back to that 3x because that's a different case. Okay. So here's the questions I got asked about homework. For 7, it said tan squared of x minus 1 equals 0. So I would take the tan squared of x, set it equal to 0, and then square root both sides, but I put plus and minus there. So it'd be tan x equals plus and minus the square root of 1, which is 1. It says on the interval of 0 to 2 pi, which means you use your full circle. So your full circle and plus and minus 1, you're going to break something to mine at some point. Just move it away. All right, so it's all the over 4's because tangent is 1 at over 4, and it's plus and minus, so it's all the over 4's. That's why it was all of them. Don't forget your plus and minus because guaranteed if that's multiple choice, half of them are going to be there as an option. And if it was multiple choice, there's no partial credit. All right, 8. So the red numbers obviously changed. This one you had to replace. There's a sine and there's a cosine, but the sine is the one that's squared. That's the one that we can replace. Sine squared plus cosine squared equals 1. So sine squared can get replaced with 1 minus cosine squared. So I would have 48 times 1 minus cosine squared x equals 48 minus 24 cosine x. Distribute, so it's 48 minus 48 cosine squared x equals 48 minus 24 cosine. And then I see a squared and a non-squared, which means get everything to one side. I like my squareds to be positive, so I'm going to move this to that way. So I'm going to add the 48 cosine squared, and I'm going to subtract the 48.
You can't, like, subtract it first.
Subtract what first?
Like, could you subtract the 48 and the 24? So, like, right next to each other?
This?
Yeah.
No, because this is part of that. You can't break that up. Then where am I at? Minus 24 cosine x, and then a positive 48 and a negative 48 cancels out. So from here, we can actually factor out. You could divide everything by 24 to make your numbers smaller. You could start with that, make your life a little bit easier. So this would be 2 cosine squared of x, that should have been an x, minus cosine of x. And then I can take out a cosine.
How did you?
You good?
When you subtracted the 48, you subtracted it from what?
Both sides. Like it came off of this side and it canceled out with this side. So I was moving it from left to right was my goal, but then it canceled from both sides. So now I get cosine equals 0 and cosine 2 cosine x minus 1 equals 0. So I'm looking for where cosine is 0, where my x would be 0 is at pi over 2 and 3 pi over 2. And I'm looking for where my cosine of x is positive 1/2, which is pi over 3 and 5 pi over 3. The directions this time gave you the interval, so I don't add or subtract anything to those. I would leave them alone. And in order from least to greatest, it would have been pi over 3, then pi over 2, then 3 pi over 2, then 5 pi over 3. Emily.
Since I got rid of response on the test, would we get points taken off if it's not good?
No, I just have to go back and like regrade it. So
But like,
in my head, I'm taking points off of you, but on the paper, I'm not.
Does response
You're taking minutes away from my life, so I'll think about at least taking points off, but no, I probably won't. I just have to go back in and regrade. So when you like are the stalkers that come to my door at the end of the day and you're like, are the tests ready? You're the reason they're not. That's what it is. Okay. Stalkers. There's multiple of you. Do you feel personally attacked? All right, tangent squared equals secant x minus 1. Again, you've got two trig functions. You have to replace one. This time there's a squared and then there's a non-squared. So I replace the squared one because that's what my Pythagorean identities are. Tan squared plus 1 equals secant squared. So I can replace my tan squared with secant. No, I'm sorry. You have to do it this way, yeah. I'm going to say I would normally do it the other way around, but they're not. One's not squared, so you have to do it this way. So this gets replaced with secant squared x minus 1 equals secant of x minus 1. You've got a squared and a non-squared. Get everything to one side. I keep the squared positive just for personal preference. So I'm going to move this one and this one. These cancel. Take out a secant. Split and solve. So if secant is 0, then cosine would be what? What happens when you flip 0? Undefined. And then secant being 1 means cosine would be 1. Reciprocal of 1 is still 1. So think about your unit circle. Is there anywhere on your unit circle where cosine is undefined? No. So this you ignore. It's not possible. Okay? It's like an extraneous root. It's not possible. But this you got to figure out. Cosine is 1 at 0. And it's at 0 to 2 pi, so we include the 0 and not the 2 pi.
If cosine is 0, then secant is undefined.
Correct.
It's always going to flip.
Yeah. Yeah.
Like
And that can happen because cosine can be 0. So secant can be undefined, but cosine's never undefined. Sine and cosine are never undefined. All right, so open to the 5-3 notes. We're going to finish that last example. We're going to skip the one that's like use your table on the graphing utility because you're never going to do that. So just skip to that last example, which is the multiple angles.
Wait, where's the cosine?
All right, so this we're going to finish, and it's called the multiple angles. That's what we're doing today. They look different, okay, because they now have something attached to the x. So in no other place did you have something attached to the x other than the squareds, which we already solved, okay? These, and sometimes they'll say in the directions like solve the multiple angle equations, and sometimes it will just say solve like your warm-up did, and you have to identify that they're different, and they're different because there's something attached to the x. So that is a multiplication of 4 times x, and this is an x divided by 3. Both result in a different kind of answer. So what you do with these first is you want to isolate the trig function. In both of these, they're already isolated. It already says sine of 4x equals 1, right? The trig function's isolated. Now what we do here is it's not sine of x equals 1, it's sine of 4x. So we first find the angle, and then instead of saying x equals that, we have to say 4x equals that. So where is sine 1? Where's my y 1? Pi over 2. And normally I would say x equals pi over 2 plus 2n pi. And that would be my answer, right? That's if this said x, but it doesn't. It says 4x. So I set 4x equal to pi over 2 plus 2n pi, and now I solve for x by doing what? Divide everything by 4. Both of these terms get the 4, and I would get x equals, this dividing by 4 is the same thing as multiplying by a fourth, so this would be pi over 8 plus 2 goes into 4 twice, n pi over 2. So not only does it change the first answer, but it changes the interval after that as well.
So what would our first answer be?
Your first answer was pi over 2, but then you had to divide that by 4. So it's pi over 8. And then every interval after that is now n pi over 2 instead of 2n pi.
Like on the quiz, would we have two different answers?
No, this would be your answer, the last answer. Remember that these can be checked like we tested them out yesterday. So I can take pi over 8 and I can plug it in there, and I can say sine of 4 times pi over 8 equals 1. 4 goes into 8 twice, so sine of pi over 2 equals 1, and sine at pi over 2 is 1. So I know I got that angle right. So you can always check these. You can check any of the solving, but you can.
With the n pi over 2.
No, you'd have to add pi over 2 to get the next angle, and then check that, and then add pi over 2 to get the next angle, and then check that, which is more work than you have time for.
Okay, so you choose the other one.
Yep. All right, so with tangent of x over 3 equals 1, the first thing I'm going to do is look for where it's already by itself. Like if there was a, let's say it said 5 tan x over 3 equals 5. What's your first step? Divide by 5. Then it becomes tan of x over 3 equals 1. Now I'm looking for where tangent's 1. Where's tangent positive 1? Pi over 4 plus n pi, right? So then x over 3 equals pi over 4 plus n pi.
Are these not restricted?
Right, because the directions don't say anything about 0 to 2 pi. These are actually harder when they're restricted. I'll explain that in a second, though.
And we only put one answer? And only pi over 4?
Because it's tangent,
Oh, yeah.
right?
Is it always going to be 1? Like you're only going to
No.
So there's going to be multiple.
It could be tan x over, oh, is it only one answer, you mean?
Like the pi.
Like only one pi over 4. Is there going to be like multiple ones?
It depends on the restriction.
Are you asking if
Like
there's
it was-
one answer here or if there's one here? Which one are you, I don't know what you're saying.
No, like I'm saying, are you always going to find the angle? Is there going to be multiple angles?
There could be multiple angles.
So you'd have to do this process more than once.
No, you would just multiply by 3 at the end more than once.
Why can't you put 5 pi over 4?
Because it's tangent, we're adding n pi, so you only do the top. Tangent without the restriction. Basically, you would be saying the same answer twice if you do that. Because by saying pi over 4 plus n pi, I'm saying if I add one pi to that, I'm saying 5 pi over 4. So you're basically just stating the answer twice. So now I have to multiply everything by 3 to get rid of the denominator because I want it to just be x. So x would equal 3 pi over 4 plus 3n pi. And that's the answer I would put.
Well, in the test, if you put both, you still wouldn't be wrong.
If you put both tangents, no, again, I have to go back in and change your answer because it's not technically right. Yeah.
How did you get x over 3 is equal to pi over 4 plus n?
So tangent is 1 at pi over 4 plus n pi.
Okay.
But it's not tangent of x, it's x over 3. So then x over 3 equals pi over 4 plus n pi, and then you've got to multiply by the 3.
Okay. And then this was the answer if there would have been a 5 for the tan.
No, I mean, it's the same. I changed it, but I kept it the same. It would have been the same. We would have just had to do one step more because this was this. Yeah.
If there's no restriction for tangent, you only do options 1 and 2.
Correct.
And then for cosine and sine.
Whole thing. So tan is top, but you add n pi. Sine and cosine is whole, but you add 2n pi.
So then what's the difference between the restriction and without the restriction with sine and cosine? You're just not
You're not adding 2n
so you
pi.
still have to do everything in the circle.
Correct. Okay, so because you just asked this question. So let's do this. All right, what if it looks like this? Divide by 2. Then what? Where is cosine positive square root 3 over 2?
Look for 2
Pi over 6 plus 2n pi and 11 pi over 6 plus 2n pi. And then to each of these we multiply by 2. So they cancel. From here it'd be pi over 3. N times 2 here would be 4n pi. That's 1. Multiply by 2 here. And you'd have 2 answers. So for sine and cosine, you'll usually have 2 answers. If it was plus and minus whatever it was, then you'd have 4 answers. So if it's a restriction, you actually have to add on the interval. It gets super messy. I'm not going to do that today.
If I don't get a test.
No, if I was on the test, I would teach you that. Yeah. Basically, if you think about what happens, like you actually have to find the interval and then you have to add that interval until you have all the values from 0 to 2 pi. So if it gave you the restriction, you'd have to take pi over 8. That's one answer. Then you'd have to take pi over 8 plus pi over 2, which is 4 pi over 8, which is 5 pi over 8. That's still on your interval. Then you have to add it again. 9 pi over 8, that's still in your interval. Then you have to add it again. That's still in your interval. And then you would add it again. And that's when it becomes bigger than your interval, so you'd stop. So if it had a fixed interval, you'd have to give all those specific answers. And that's what we're not going to do. Yeah.
Could you add, for example, to
Yeah, well, let me go back to the warm-up last. So the last one on the warm-up that we did this side of it, right? We did that side of it. But this would now be equal to 0. This was 1 from the warm-up. We just didn't do the left side because it had 3x. So it's a multiple angle. So where's tangent 0? 0 plus n pi, right? Then I would divide everything by 3, and I'd still get 0, but I'd get n pi over 3. So if this is multiple choice, it's actually just going to say n pi over 3 instead of 0 plus n pi over 3. And if it was on the interval of 0 to 2 pi, I'd have to take n pi over 3, make it 1, so it'd be pi over 3. Then I'd have to add n pi over 3 to it again, and it'd be 2 pi over 3. Then I'd have to add n pi over 3 to it again, and it'd be 3 pi over 3, which is pi. And then I'd have to add to it again, and it'd be 4 pi over 3. And then I'd have to add to it again, and it'd be 5 pi over 3. Add to it again, and it's 2 pi, which means each of these answers would be true if it gave you that interval.
But wasn't this with restrictions? So doesn't that mean there's no n pi?
So that's why it's messy with multiple angles. With multiple angles, if they give you the restriction, you actually have to find them using the interval. But then you don't add the interval, you list them. So that's why I said we're not gonna do that
So we wouldn't get a question like number 1
with a restriction.
So you were doing
Your multiple angle is not gonna be with a restriction.
and so without restriction it's just n pi over 3.
Correct. Vanessa.
like why would pi also be?
Because you don't need pi because it's already there. So by saying 0 plus n pi, you're already saying pi. So the tangent one is 0 to pi, but you don't include the pi. Does that make sense? Because you're adding pi. So if you had 0 and you add pi, it is pi. You already have it. Questions? All right, so there's going to be 2 things for, on your to-do list and on the module is a thing that says there's 2 things for today's date. Okay, 1 is actually graded, and that is the homework for, let me actually make this student view. That's the homework for tonight that has 5-3. It has 1 practice problem from 5-1 just so that you can practice the typing in, okay? But I put it on Canvas so that you have to learn how to type it in. I don't want the typing in to be what hangs you up on Thursday's test, okay?
The extra practices are homework.
So the extra practice is the homework and it will be graded. Like I'll grade it like I do a web assign. So the questions are there. They're all fill in the blank so you can practice filling in with PI instead of pi. So you can practice in no spaces, all that stuff. And in order of least to greatest. And then the last question is your work that you're going to upload. So if you split your screen and you work it out, take a screenshot of that. You'll upload that as your work. If for some reason you get a question wrong, those are 20 points apiece. If you get the question wrong, but you have the work, it's just like web assign, I'll give it back to you. Does that make sense? It's not going to happen right away, so don't freak out at your grade right away. When I grade them, it will go back to you, okay? So these questions are there. I allowed 2 attempts just in case something happens, but there's more than 1 question in the bank, so you don't want to do it if you don't have, because then you'll get a new question. So your goal is to start it when you're ready. And don't hit submit. There's no time limit. So don't hit submit, just like WebAssign. Don't hit submit until you're done. So you could literally hit start now, and you could take 24 hours to work it out until tomorrow, okay?
So
Just don't hit submit.
Even if, like, I start it at, like, 5
Yeah.
and I get off.
There's no limit. Just don't hit the button that says submit. Yeah. If you hit submit, I give you one other option. You can go back in and do it again, but you might get new questions. Yeah. You can exit. Yeah, you can exit and go back in because there's no restriction on time. That's the first thing, and that has all the multiple angles things, and then it has like 1 from 5-1. Then also on your on the module is your test review. So my advice is it's really only 2 major topics. Like 5-1 and 5-2 are kind of put together, and then everything from 5-3 is the other half, and it's literally half and half. Like there's 10 questions from 5-1, 5-2, and then there's 10 questions from the equations. So if you can start your review, my advice would be to start it so that on tomorrow, at 1, I'm not pissed off at you because you didn't do any work. 2, you know what you need help with so I can help you before the test day. Why is this not loading? So that is, it says NG because it's not graded. Hang on, sorry. Come on. So one more thing, guys, is that on the review, I'll just give you a couple instructions. They're on there, but people don't read. Let's face it. Okay, it says NG 5-1 to 5-3 review. One thing is there's 2. There's a review at the top. So that would be my advice. Try to do that 5. It's only 5 questions, the little assignment that I put up there. Try to do that and at least start the top one. And then there's an extra review at the bottom. For the top one, this goes through 5-4. And we didn't do 5-4 yet. Remember, that's what's going to be on the quiz. So stop at just page 1. Just page 1 is 5-1 to 5-3. And then on the bottom, I also put this in the instructions, but these are the multiple angle ones, and they say to do it on the interval. Don't do it on the interval, okay? Make your life easier. The answers for the odds are on the link for the calc chat, and it says it, chapter 5, section R, okay? And then the answers to the even are here. And then obviously there's the extra review. Ideally, you do this tonight, as much of it as you can, and then the extra review tomorrow, okay? The more practice you can get the verifying, the easier it's going to be.
This is our last test, right?
Correct. Questions? Okay.